All right. This week, we're going to tell you how to take some of those fancy machine learning models that we've trained in previous weeks and put them in production. That is to say, to actually use them out in the real world. Um, One small caveat. Um, we're really showing you how to do that only if the model you want to put in production is the logistic regression. So in our experience with the logistic regression, we found that that didn't require a lot of compute time. And that's because it's really just an equation with some coefficients that we plug in, take in the inputs from our features, and just multiply them by some numbers and raise something to a power and divide by something. It's pretty straightforward as far as a computational approach goes. And so we're going to implement it for the example we've used in previous weeks, which is the should we close school model. And we're going to do it in an interesting way, I think. We're going to implement it in a spreadsheet. Specifically, we're going to implement it in Google Sheets. So a nice byproduct of this is that you're going to learn how to make a custom function in Google Sheets, which I think is something after you've done it, it'll be hard to go back because building custom functions is just awesome. All right. So let's remind ourselves real quick about the logistic regression and what that looks like. We've seen a slide like this before, although I did something a little different here. Instead of showing you the equation here for the logistic regression with just a single input, I've shown it with multiple inputs. So we've got these input x prime and x prime prime. And you'll see that these b's, these b prime and b prime prime, are what we call coefficients, which is to say that you multiply them by the inputs to help get the answer you want in this equation. This b just all by itself, that's the intercept. It turns out that actually if we go back over and we look at our code for our logistic regression, we've actually turned the intercept off on how we did our logistic regression. So we're not going to get that first value. We'll only get the coefficients that correspond with the inputs we have. So actually, what I've done is I've created a new cell right below here. I've run everything, gotten to the point here. Well, remember, these models are not great. We knew they weren't great because we don't have a lot of data, but we just want to sort of figure out how can we implement them if we wanted to. So what I'm going to do is I'm just going to show us the columns of that training data to remind us what our features were. So here are our features: our accumulation, the minimum temperature, the maximum temperature, and the maximum wind speed. And then we have this last column, which is closed. That was not one of our features. That was our target. So we're not going to have a coefficient associated with that. So I have this other little thing here, classifier _1, which remember was what the logistic regression was, and dot coef for coefficient. And what it's going to do is going to print out the coefficients for me. Now, what these coefficients do in a logistic regression is they tell us about how important the individual features were. So first thing, if I just look at the absolute value of these coefficients, which is to say the size of the number without a plus or a minus in front of it, we've got 0.5, 0.03, 0.1, and 0.1. So this clearly is the most important feature. Well, that was our accumulation. Okay, so this is much more important to whether or not I'm going to close school than any of these other features. The other thing we notice is the sign. This is positive, so as accumulation goes up, the odds that I'm going to close school go up. Likewise with wind speed, as the wind speed goes up, so too do the odds that I'm going to close school. But interestingly, if the maximum temperature goes up, the odds I'm going to close school go down. Same with the minimum temperature. If it goes up, then it goes down. That's because the min and the max, you can see they have this negative, these negative values. And that makes sense, right? As the temperature gets warmer, it's going to be less likely that we close school. So those all sort of directionally and sort of relative to each other in size make sense. And that's what we would expect from a logistic regression. And these coefficients is we can look at them and they can tell us something about how important each of the features are. What we're going to want to do is take these coefficients and put them into an equation that looks something like this, where we bring in our inputs, and then we'll get ourselves out the answer we sort of expect. So let's go ahead and take these. I'm just going to copy those there. And I've made myself a brand new spreadsheet. And what I want to do is let's make a column for each of those. So we've got accumulation, min, max, and wind. Let's just do that. So I've got now 4 columns. And then we'll say close closed, question mark, okay? So let's do that there. So I'm gonna have some accumulation, let's say like, let's just do 0 inches. The minimum temperature was 32, but the maximum temperature was 70, and the wind was 0. And the question is school going to be closed on that day? And so in order to do that, I want to be able to take these coefficients. I'm just going to copy these again because we're going to use them. And I want to be able to multiply them by these guys and then put them into an equation that looks like this to get myself an answer. What I'm going to do, though, is I'm going to create a custom function. So here, if you go up in Google Sheets to Tools, and then you click on Script Editor, it's going to open up this script editor here. And here you actually can create functions that will go with your spreadsheet. You got to give it a name. So we'll call it closed, question mark. All right. And did it actually, maybe it doesn't let me do a question mark in there. Closed. Okay. Oh, it's saving it. There we go. Okay. So you'll recognize this. This is this looks a lot like JavaScript, and that's because effectively it is. This is Google's app script. It's effectively JavaScript, but it can run inside things, inside Google Apps. And so that's that. I just realized you can see my email there, so that's exciting. Not like you couldn't have guessed that email. All right, so here is a function called my function. I want to make a new function. I'm going to call this function closed. And then I need to give inputs. Well, I'm going to want to have inputs for each of my 4 things, for accumulation, for the minimum temperature, for the maximum temperature, and for the wind. These are each of my 4 features. And then what I'm going to want to do is I'm going to return some value. Now that value I'm going to want to return is going to want to look like this, the output of this equation. So it's going to be 1 divided by 1, right? 1 divided by 1 plus Euler's number there, which is E. Right, so plus, and the way you do that here is math exponent. And then inside there, we're going to want to have negative of something, and then I'd have my coefficients. So I'm going to have my, remember I pasted, I cut those coefficients. Here are my coefficients. I'm going to have that times accumulation. And I should spell things similar. There we go. Well, not similar, I should spell things the same. And then I should multiply that by the min. And I'm taking rid of, making sure this is a nice equation here because getting rid of the commas and stuff. And then here's my max. And here I should put a plus because otherwise it's not going to know what I'm doing. The other ones it has the minus. And wind. And now I just check all my parentheticals. Everything looks right. So now what I do is I'm going to go ahead. I'm just going to hit save. Unexpected token. What did I do here? Line 3. Oh, I'm saying return equals. You don't set up, this is an expression, not an equation. It's not like return is a variable. Remember, return just echoes, will send out what you put in. So basically it's going to take whatever the value of this function will take in these 4 inputs and then just return the output of this. So I'm going to go ahead, I just did a Control S to save. So now I've saved that. There's a function called closed. And now what I'm going to do is, now I can call that function here the way I would any function. I just do an equals to say I'm going to do an equation. And then I say closed. And then I'm going to tell it A1 is the first feature I put in. Then, oh, not A1, A2, sorry. then B2, then C2, then D2, and that's my equation. And if I do that, it's going to think about it a second, and there is the output. I want to turn that into a percentage, so let's go ahead and we'll just take that whole column, turn it into a percent. And what I see is that there's a 0.01% chance that I will be closed on a day like that. What if I ramp the accumulation up to 100 inches? 100% chance that it'll be closed. I make it something like 7 inches. Okay, 30% chance. It's still getting pretty warm. What if I make it so that the maximum temperature is down to 32 from 70? Okay, 20% chance. Okay, what was it before? I already forgot. There was a 30% chance, so actually made it go down. Again, this model is not a great model, but I think if we make it 32, 20% chance it'll close. If we make, what if we make this like, oops, 0, 0, 100. Yeah, it's 100% chance, right? So, but if I make this like 5, with these really cold temperatures, obviously that's really making it gonna be very unlikely. If I make the temperature a little warmer, then it gets much higher. So, so this behaves sort of the way we would expect. It takes in those values and then spits out a thing here. So I could then have a whole slew of 100 inches and 32, 0. That's good. Makes that 70. I could do 7 inches. 30, 1 to 15, right? So you could have that, and then the nice thing is what you could do is you could take this and you just expand these down here, and then you could see what they all are. So you could imagine doing a situation where you had something similar to what we discussed above, which was implementing the sort of challenge you had with the Dewey, Cheatham, and Howe data, which is that you might have a Google form where you input data. That data then came into a sheet like this. You could have some other, you could do some other fancy formula work to transform it into numbers. And then you could have this function run on that data so that as data came in from your Google form, you could get that take or no take right in a column here using your custom function and the logistic regression you did. So that's sort of your setup. We found the coefficients for our logistic regression. We know that has to conform to an equation that looks like this, where we basically just add plus coefficient times feature for every new feature. And we went ahead and we created a spreadsheet and created our own custom function that we then can use in the spreadsheet to implement our model. Now, I hope you found that was fun. Now, the other thing that you'll notice is on the page, when I embed this video, I don't actually tell you if you have to turn anything in, because you don't have to turn anything in. I left that blank so that you would, like watch along and follow along and do it. But yeah, on this last week, before we move entirely sort of devoted almost entirely to our final project, I'm not giving you any additional project work, which is why the amount of time spent on this mission is only the time of this video. So there you go. I think this is a pretty cool thing. Once you realize, one, you've just now been able to take that machine learning model that you made and put it in production in a way that you can always have access to it, and that's pretty cool. It's a little silly to call a logistic regression machine learning model, but it sort of meets the criteria, and the reality is it does, as we've seen, often does almost as good a job or just as good a job as some more complicated algorithms. But the fun thing that I really like about this is just that you now know how to make these custom functions. So you could, in this same thing here, you can make a whole bunch of other functions. And so you could actually, now you can like superpower your spreadsheets by making cool functions that bring in inputs and do all sorts of cool things. And because you know a little JavaScript, you now can do that. You now have the skills to sort of, again, extend the tools that you're working with and do even more things with them. So hopefully that's a powerful and empowering thing for you to know. All right then, thank you.